In the last 300 years, we have discovered the laws that govern the universe in all but the most extreme conditions. I think there is a reasonable chance that we may find a complete set of laws by the end of the century if we don't blow ourselves up first. If we do find a complete unified theory, it will be a great triumph, not just for scientists, but for ordinary people as well. In time, the unified theory would be simplified and taught in schools, at least in outline. Then, everyone would have some idea of how the universe works.
Well, that is a tremendous vision. Now, Carl Sagan, you wrote an introduction to the book, and one of the striking things that you said is that it's only children nowadays who ask the big questions because they don't know enough not to.
What I was trying to get across was the notion that the school systems, it seems to me, have a attitude of discouragement of asking fundamental questions. If a 5 or 6 year old asks why the moon is round or why grass is green, the usual adult answer, at least in my experience, is to discourage the child. Say, what shape did you expect the moon to be? Square? Or what color did you expect the grass to be? Blue? Instead of saying that those are interesting questions, let's try to find out the answer, or maybe nobody knows the answer, and when you grow up, you'll be able to discover the answer. It would be very healthy for the human species if there were less discouragement and more scientists.
Arthur Clarke.
One of the reasons why I write science fiction is because it does free the imagination and does inspire people to become scientists and astronauts. Many astronauts have made me feel a very old man by coming up and saying to me, you know, your books turned me on when I was a small boy.
Excellent. Now, I have planned a reasonably finite structure for our little colloquium, and I'd like to start, if I may, with Professor Hawking. How did the universe start? With a Big Bang?
We observe that distant galaxies are moving away from us. This means that they must have been closer together in the past. In fact, one can show that all the galaxies must have been on top of each other about 15 billion years ago. This was a real Big Bang, not a puny thing that took place on the stock exchange a couple of years ago. It was the beginning of the universe and of time itself. Anything that happened before the Big Bang could not affect what happened after. So we can neglect events before the Big Bang and say that time began at the Big Bang. After the Big Bang, we believe that the universe expanded in a very rapid, inflationary manner. Again, this inflation in the universe quite puts modern economic inflation in the shade. An increase of billions of percent in a tiny fraction of a second. Of course, that was before the present government. During the inflationary period, the universe borrowed heavily from its gravitational energy to finance the creation of more matter. The result was a triumph for the economics of Keynes. A vigorous and expanding universe filled with material objects. The debt of gravitational energy will not have to be repaid until the end of the universe.
Well, here we are on a planet which is about 5,000 million years old. The sun around which it goes is not much older. It is part of a galaxy which is perhaps 10 or 12,000 million years old, which is one of perhaps hundreds of thousands of millions of other galaxies. And none of this, planets, suns, galaxies, was around at the time of the Big Bang. At the time of the Big Bang, there was energy, elementary particles, which slowly evolved into the kind of universe we know today. We are the product of a grand evolutionary sequence, cosmic evolution, about which we are only occasionally aware. One of the great accomplishments of Dr. Hawking is to plug us better in to the knowledge of this long evolutionary sequence. Well, as Dr. Hawking said, the galaxies are expanding, running away from each other. The further away they are from each other, the faster they are running away. If you run the cosmic movie back into time, you come to a moment, perhaps 15,000 million years ago, in which all the matter in the universe was touching in, if you like, a point. And a key unanswered and perhaps unanswerable question is, where did all of that matter energy come from? What was before that? And if it was made from nothing, who made it? And who made the maker? And of course, an infinite regress behind that. As far as I know, nothing in the way, and the expansion continues. The question is whether there is sufficient matter in the universe, matter that we have not yet counted, that will slow the expansion down, stop it, and have the expanding universe followed by a collapsing universe, or whether there is not enough matter to stop the expansion, and so the expansion then continues forever. This is an observational question which is still unresolved, and the Hubble Space Telescope, which who knows might be launched next year if we're lucky, might answer this question. No, not inevitably. It depends on how much matter there is in the universe, which is a still unsolved issue. I should say that the prevailing opinion is that the universe will continue expanding forever, but that, in my opinion, is by no means a very secure conclusion.
Well, one would like to think that we will end with a bang. Of course, we'll never know. It is rather a long way in the future. Some billions, tens of billions, possibly even much further in the future. And as Carl said, we may have the answers to these questions in a very few years if the Hubble Space Telescope gets successfully into orbit and can peer out to the boundaries of the universe. Well, I think the human race, if it survives the next few years, will go on to colonize first the solar system and then to send ships out to the stars and ultimately perhaps to other galaxies. But if the expansion of the universe is fast enough, we will never be able to keep up with it.
In our theories, there are two kinds of time. There is what is called real time. This is a kind of time that is measured by a clock. The time that we feel passing, the time in which we grow older. Then there is imaginary time. Of course, imaginary time is an idea that science fiction writers, like Arthur, have used in their stories. But imaginary time is also a well-defined mathematical concept. It can be thought of as a direction of time that is at right angles to ordinary, real time, in a certain sense. The universe has a beginning in real time, at the Big Bang. And it may well have an end, if it collapses to a big crunch. But in imaginary time, it has no beginning or end. Rather, imaginary time is closed in on itself, like the surface of the Earth. The surface of the Earth doesn't have any beginning or end. I know, because I have been round the world, and I didn't fall off. Individual particles can travel through imaginary time and arrive back at an earlier real time. But I don't believe that people will ever be able to travel back in time, like in the film, Back to the Future.
1.21 gigawatts!
Well, the first thing I would say is not to feel bad if it's not immediately intuitively obvious. Our ability to understand things instantly, so-called common sense, derives from a certain range of size and speed and duration that are appropriate for human existence. We know about things from 1/10 of a millimeter to a few kilometers, from a fraction of a second to a lifetime, and so on. So when we are dealing with matters of quantum physics, where particles have a size of 10 to the minus 13th centimeters, or in cosmology, where we are talking about 10 billion light years or more, it is very reasonable that our intuition is not adequate to the task. One point I'd like to make about this is that every human culture has a set of creation myths, but they're in the realm of mythology or religion or folklore, and they are, of course, all mutually inconsistent. The great thing that is happening in our time is that we are able, through a method which can actually make some progress towards the real universe out there, to find out something about origins, and this is the scientific method applied to the science of cosmology. Well, first off, I would say we have little choice in the matter. That is, we have already announced, or rather I should say, Magnus, you fellows have already announced the fact that there is a low-level technical civilization in this part of the galaxy, because television programs get out at the speed of light, and since any other civilization who detects those signals is unlikely to be at or before our state of technological advance, since we've just invented radio technology, so to say, they are much more likely to be in our technological future. And the question as to whether their intentions are benign or otherwise is, of course, of interest, but we have nothing to say about the matter. So therefore, I think we might as well hope that it's benign if they're out there. From my point of view, the search for extraterrestrial life, and especially the search for extraterrestrial intelligence, is one of the key philosophical, scientific, and human questions that have been posed. But we are at the very beginning of searching. Surely it is important for us to know the answer. The first large-scale commercial broadcasting on the Earth was in the late 1940s. So that's what, 40 years ago. So you must imagine a spherical wave expanding out from the Earth at the velocity of light, which contains all the dreary programs of the late 1940s. Since then, that expanding spherical wave containing the news of a developing civilization on Earth has traveled some 40 light years. Suppose that there are no civilizations closer than 40 light years. Perhaps they're not here because they don't know we are about just yet. But in time, the message gets to them, and perhaps they send a little expedition to look us over.
Yes, I'm an optimist, and I believe that any malevolent super-civilization would rapidly self-destruct, as we may be in the process of doing ourselves. So if we do have contact, physical contact with aliens, I think it will be benign.
My frivolous mind is much
If there are
taken...
very intelligent beings reasonably near, why have they not visited us?
Well, that's a very good question. Let's throw it right across to Arthur Clarke.
There are literally dozens of answers to this. They may have come in the remote past. They may be visiting us every 10,000 years. I mean, the universe is a huge place, and even if there are fleets of survey ships going all over the cosmos, we shouldn't expect visitors less than, I'd say, every 1,000 years or so. They may know all about us, and they may have put a quarantine around our planet for pretty good reasons. They may be totally uninterested in us. They may be so much higher that they, we're just beneath contempt, if you like. You can speculate endlessly. I think we should just wait and try and get more evidence.
My guess is that it'd be something like, oh, look, another artifact from some extremely primitive civilization. Which one is this? But then some degree of thanks that we were thoughtful enough to send a message into the far future, which could in no way benefit us, certainly a selfless act. And perhaps it would be recognized as a hopeful and optimistic gesture by an emerging civilization just setting foot into the great galactic wilderness.
I know what is going to happen to your voyagers, Carl. They'll be overtaken one day by a terrestrial spaceship and brought back to the Smithsonian.
It's certainly technologically possible, but I hope they let it go on its original mission.